I would now like to welcome our next speaker. Our next speaker is Daniel Okpaise, and they will be giving a talk on molecular detection of HIV-1 DNA in HIV-exposed infants previously diagnosed negative. So you're now welcome to share your slides and unmute yourself.
Thank you very much. Thank you, everyone. Hi, everyone. Again, my name is Daniel Okpaise. I'm grateful to the organizing committee to share my research on the molecular detection of HIV-1 DNA in infants previously diagnosed as negative at the University College Hospital, Ibadan. Here is the outline. Currently in the world, we have over 2.8 million children who are currently living with HIV, and Nigeria accounts for 7.6% of that population. So this puts Nigeria at a very serious position in terms of solving the issue or helping with this issue of infant HIV. And Nigeria also, like its neighboring countries in sub-Saharan Africa, has a diverse viral population. With various parts of the country, like Kaduna, Maiduguri, Ibadan, Lagos. Ibadan was where the study was done. Just Abuja, representing the various geopolitical zones, showing diverse groups of the virus, from circulating recombinants to subtype G and others. Currently, this is a picture of where the PMTC coverage is for Nigeria, with Nigeria being amongst the country that has some of the lowest PMTC coverage for HIV-1. And now this study's main goal was to look at what was the role of misdiagnosis due to viral diversity amongst HIV-exposed children who were born to mothers living with HIV. And so we have data on the role of these mutations or this diversity, how it affects antiretroviral therapy and how it affects transmission, but there's no data on how does this affect diagnosis. And because we know that diagnosis is important in early infant diagnosis for these children, because it ensures that, okay, a child who is born to a HIV positive mother is properly diagnosed after birth, either as positive or negative, and a child who is properly diagnosed as positive can then go on to antiretroviral therapy, and a child who is negative, can then live a normal life without antiretroviral therapy. And with the low amount of PMTC coverage for these children and mothers, this means that there's also a population of children who are being missed out for even PMTC coverage, minus the low population of PMTC coverage for those who were correctly detected. And so this research looked at how could we improve diagnosis, how could we ensure that more and more children were accurately diagnosed as either positive or negative, and thereby help Nigeria also attain the 2030 goal of the UNIAIDS of 95%. And so we looked to develop an effective assay to ably detect regional viral mutants, because previous assays or previous commercial assays that are being used utilize generic primers, which were more predisposed to accurately diagnose B subtypes of HIV-1. But like I showed earlier in the map, Nigeria has a diverse group of viral diversity and especially non-B subtypes. And this means that if you're utilizing an assay that can detect B subtypes more accurately than non-B subtypes, this means that certain mutants will be missed out, and such children will miss out on important antiretroviral therapy. They will miss out on proper treatment. And I would like to add that the diagnosis usually here in Nigeria is done at 6 weeks of age, when the child is born at 6 weeks, and it's quite qualitative, it's not quantitative compared to what we do for adults, where after we do antibody tests, we can do, if the adult is positive, viral load can be done afterwards. But over here, it's qualitative, whereby it's just conventional, positive or negative. So there's no value to it. There's no quantitative value that can determine, is it a low titer, is it a high titer. And most commercial assays utilized here in Nigeria actually have lower detection limits. So this means that if a child also has a viral load, for example, that's below the detection limit, it means it will not be detected. And adding that to also the previous thing I talked about of generic primers being used by these assays. And a study done in 2015 pointed out the issues of false negativity within PCR tests utilized for infants. For this study, we looked at how could we improve the detection amongst this group, amongst children born to HIV-positive mothers. And we looked at previous assays were built or designed to detect the GAG region and the LTR region of the virus because these places are highly conserved. But previous studies have also shown, like the study in the previous slide has shown that there are certain areas of variability in the GAG region which still allows for misdiagnosis. And we then looked at, could we improve the diagnostic assay or process by making it a 3-gene or a 3-protein detection assay. And we looked at what could be a candidate gene or protein to use for this detection. And the NEF gene was our best chance because of its role in the early stages of viral pathogenesis and its abundant expression during that process. So this means that we can also account for more and more mutants or more viral mutants amongst children born to these parents, or to these women. Methodology. So firstly, we had to get ethical approval because we had to use samples of children who were being brought in for early infant diagnosis, The next step was to design primers that were effective for detecting the mutants, the prevalent mutants within that locality of Ibadan. And we had to test the sequence alignment and the appropriateness of these primers against partial genome sequences for the NEF region and other regions and the GAG region. And after this had been designed, we had to optimize our assays to ensure that they were as effective or as accurate as the current assays that were being used or better accurate. And in doing this, we had to test truly positive and truly negative samples that had been sequenced from a previous study. And from this, we're able to have a sensitivity of 99% and a specificity of 98% in detection of truly negative and truly positive samples from a previous study. And after doing this, we had our genome extraction, and then we had a semi-nested qPCR process, which involved us using 3 different NEF primers for the processes, and then the amplicons were viewed via gel electrophoresis. Our results, so during our studies, we used 102 samples, whole blood samples. We had 20 detectable HIV DNA from these samples, which gave us a prevalence of 19.6% amongst this population of HIV-exposed infants. And this was quite a huge number because this was as close as 20%, showing that a huge amount of children were being missed from this population. And the first thing we had to do after this assay, after this result, was to call back the children, to share this research firstly with the EPIN PEPA group, and then call back the mothers of these infants, so the infants could be brought back in for further retesting and then put on ART. We also noticed there was a higher prevalence amongst children who were 0 to 6 months compared to those who were older than 6 months, 12 months and above. There was a similar rate of positivity or false negativity amongst male and female babies. And also, we also noticed that the HRT status or the antiretroviral therapy status of the mothers also play a role in this detection. We noticed that children whose mothers were not on any form of antiretroviral therapy had a 50% chance of being tested false negative compared to those who received one form of ART at either during pregnancy, before pregnancy. This was the prevalence according to age groups. This table shows based on PMTC and prevalence based on PMTC, sorry. In conclusion, from our research, we looked at the fact that the promise of multi-gene or multi-protein detection assays would help with effective diagnosis for infants, not just within Nigeria or Sub-Saharan Africa, but in other parts of the world, because a good amount of assays being used commercially have been developed to detect prevalent strains or subtypes. And this means that in places where we have a huge diversity for the virus, a lot of times these strains will be missed out. So this means that, like I said earlier, a child who has this strain or an infant who has this strain would miss out on ART and be diagnosed as negative. Meanwhile, that child is actually positive. And we also were able to look at the importance of specific primers rather than generic primers, like I said earlier, which are developed or designed to detect certain subtypes more accurately than the others. And our research also pointed out the importance for the review of the early infant diagnosis process being used in this part of the world, rather than it just being qualitative, meaning that there are no numerical values to give for better diagnosis or effective diagnosis. If a quantitative part could be added to this assay or this detection process, then it could account for certain viral issues whereby a child has a viral load that's probably lower than the detection limit of that assay. And in cases where we even have inconclusive results, if we have a quantitative assay, that can be accounted for. And also, like I showed earlier, that there's a need for a better PMTC coverage based on the fact that Nigeria has one of the lowest PMTC coverages. And an increased PM coverage means that there's less likely for vertical transmission or transmission of the virus from the mother to the child. And this reduces the chances of even false negativity or other misdiagnosis. Future directions, we are looking at sequencing the detected samples to determine the exact subtypes that have accounted for this false negativity, and so that this can help with the development of more effective assays or better assays to help account for more and more subtypes. We're also looking at the possibility of a more national-based study whereby we are collecting samples and from various parts of the country. And this helps improve the power of the study, allows us to look at certain other things that could affect or determine certain relationship or associations, such as age, such as maybe breastfeeding status, such as other factors that could have an effect or have associations with this process, and also provide a larger database for even further research, either towards the, therapeutics or diagnostics. So these are some future directions we are looking to pursue. For acknowledgement, I would like to acknowledge my supervisors, Professor Georgina Odaibo, the late Professor Laleye, my co-advisors, Dr. Olushola Batunde, Dr. Olukunle Oluwasemowo, and my colleagues and family for their support during this process. Thank you.
Thank you very much for that talk. Feel free to leave your presentation up, but to answer questions, you can also take it down. It is up to you. But the first question that we do have is the cost or accessibility of these diagnostics an issue in Nigeria? And a follow-up to that would be, will better diagnostics mean more access to treatments?
Okay, so I will take the first one. The cost is not actually an issue because currently most primary healthcare centers have a form of testing for these children. And so it's more of recruiting the mothers and following up for them to come and have access to it. So that's one of the issues that also been worked on. But as regards cost, there are subsidized forms covered by funding from the APIN PEPFAR group, which helps with this. And also, a better assay would account for more access, but access currently would have to do around more awareness, more enlightenment for not just mothers, but for the community, so that this is included. So more mothers are recruited to either stay on the antiretroviral therapy, get initially tested, know their status, and stay on those drugs during and after pregnancy, and follow certain processes. So I would say cost is not an issue, more of access, but awareness could help better with that.
Thank you. And then one question that we do have from the Q&A section is, can you explain why you chose NEF from infected CD45 microvesicles?
Okay, so that was in reference to the high amount of expression of the virus, of the NEF gene. So we looked at the fact that since it had high expression during the early stages, then this means that it will also be a key anchor for early detection, since these children are, detection is done for these children, or diagnosis is done for the infants at 6 weeks old, before other proteins or viral proteins are, have an increased titer.
Thank you. And maybe we'll just take a moment if anyone has any other questions that they would like to pose in the chat or in the Q&A section.
I think Pavan Raj had a comment.
So we do have a comment that I will just let you know that you can comment on. So the stereotypes of HIV-1 and 2 really vary with regions, and many diagnostic tests focus on major published epidemiological patterns and serotype dominance that change and need monitoring from such studies too.
Sorry, could you come again?
Yes. So the stereotypes of HIV-1 and 2 vary between regions, and many diagnostic tests focus on major published epidemiological patterns and serotype dominance that change, and monitoring these from different studies.
Okay, so yeah, serotypes actually differ across various, if I heard you right, differ across various geographical zones within the country. But I wouldn't say there are quite stereotypes to that. But more research could probably be done to give a more extensive database for the various stereotypes that are going across the various groups or the various populations or geographic zones within the country.
Thank you very much. And with that, I will thank you for your talk, and we will now move on to our next speaker of the day,